Hey, this is Mr. Masonette, and what we're going to do in this very interesting problem is try to figure out what fraction of this larger square here is shaded by these smaller blue squares. All right, the first thing that we're going to do is add a diagonal across the length of the square here. Now, we should understand that that creates a line of symmetry, whereas if we were to fold this side upon this side, any lines that match up would be congruent. So if you take a look at this line right here, if we were to draw a line right here, we could see that they would be the same length. So what we're going to do is we're going to go ahead and label this side of our square A, and then we're going to understand that every side of that square is A because squares have 4 equal sides, and we should also understand that this is a square that is congruent to this square. And once again, if we were to fold this square upon this line of symmetry here, we would see that this line here would match up with this line perfectly, meaning that this line is the same length of this line. Therefore, we can label both of those length A. All right, what we're going to do next is we're going to take this tilted blue square and draw a square that touches each one of these squares' vertices. So this blue square is now inscribed inside this yellow square. And what we have created are 4 congruent right triangles. Now, what we should notice right here is that we already have the length of one side of one of these right triangles. The short leg of this right triangle here, we already labeled A. And because these other 3 are congruent to this 4th right triangle, this length right here must be A, as is this length, as is this length. So let us go ahead and label those individual sides A. Now, with any right triangle, we normally label the 3 sides A, B, and C. Well, this leg right here is A, and the second leg we always label B. And we can see that all of the sides that we just highlighted in green here are congruent to each other, so we can label each one of those lengths B. Now, if we take a look at this square right here, we can see that its width right here is B, which means its height also must be B, as is this length, this length, this length, and this length. So right here, we have a pair of congruent squares, and each of them have a length of B. And of course, going back to our 4 right triangles here, which are congruent to each other, we still have to label this third side, which is going to be labeled side C. All right, now to find the area of any square, you just take the length of one side and multiply that length by itself, or square it. So to find the area of this square, it would just be A squared. Now to find the area of this square, it's going to be B squared. And to find the area of this square, of course, it is C squared. So if we were to add up all 3 of those areas, this would be equal to the combined area of the 3 blue squares. All right, but we still have a lot of work to do. We didn't even come close to figuring out what fraction of this is shaded here. So let us go ahead and figure out what facts we can come up with based on what we have here. All right, now another thing that we should notice with these 4 congruent right triangles is that we can use the Pythagorean theorem. That might come in handy at some point. So what we're going to do is just say that C squared is equal to A squared plus B squared. All right, so we're just going to table that for now. We may come back to that when solving. All right, now let us take a look at this larger square right here. Now, ultimately, to find the fraction of what is shaded, we are trying to find the shaded area as our numerator and the total area for the denominator, which means shaded and unshaded. So as part of our calculation here, we have to account for the area of this larger square here. Now, in order to find the area of a square, once again, we multiply the length of one side by its other side, which are the same. Basically, we square one length by itself. So let us take a look at the length of this side. We can see that the distance from here to here is A, and from here to here is A, from here to here is B, and from here to here is A. So the length of this side here, we can summarize as 3A plus B. Now, we could just square this side, but we should notice that this side here is written in different terms. Here we have a distance of B plus A plus B. So we could summarize this as A plus 2B. And because this is a square, this side is equal to this side. So we can say 3A plus B is equal to A plus 2B. So let us go ahead and put each one of these variables on different sides of our equal sign and see if we can solve in terms of A or in terms of B. Because when we do that in algebra, if we know what A is equal to, we could plug that thing into any A value, or if we know what B is, we can plug that value into any B term. So let us go ahead and move this positive A to the other side by subtracting A, and that's going to give us 2A on this side. And then we're going to subtract this B from itself so we can move it over here. 2B minus 1B is, of course, 1B, or just B. So now we have an equation in terms of B. Anywhere where we see just a B in an equation, we can substitute that with a 2A because they mean the same thing. All right, I want to go back to this part right here before we cancel things out and rewrote this as 2A equals B. So I'm going to rewrite this as 3A plus B, and then this is going to be A plus 2B. All right, what I'm going to do is I'm just going to take one of these sides. I'm going to take this side right here, and I'm going to go ahead and just square that. Now, before I go ahead and square that, we know that B is equal to 2A. So what I'm going to do is I'm going to substitute for this B here 2A. So we can rewrite this as A plus 2 times 2A, and then square that. All right, now if we do 2 times 2A, that is going to give us 4A, and we still have this 1A at the beginning, and then we have to square that, and 1A plus 4A, of course, is equal to 5A, and if we square 5A, that is going to be equal to 25A to the second power. So this right here represents the area of this large square right here. Now remember, the fraction we're looking for is the shaded compared to the shaded and the unshaded. So for now, we know that our total is 25A squared. I'm not sure at this point if we can simplify this more or not, but we're going to table that just for a moment. All right, let us go back to the shaded part, which we already know is going to be A squared plus B squared plus C squared. Now, one thing that we should notice is because of the Pythagorean theorem, we know that C squared is going to be equal to A squared plus B squared. And notice with this equation that we came up with that expresses or reflects the combined area of these three squares, that we have a C squared right here. Because C squared is equal to A squared plus B squared, we can substitute C squared with A squared plus B squared. So what we're going to do is we're going to rewrite this equation as A squared plus B squared plus, and then we substitute this with A squared plus B squared. Now, what that means is we have two sets of A squared plus B squared. So we can summarize that as doubling A squared plus B squared. Now we also know from our earlier calculation that any time that we have a letter B, it is the same thing as 2A. So what we can do is we can substitute this B here with a 2A. So let us go ahead and write 2 times A squared plus, and then we're going to put parentheses where this B is, and we're going to stick inside there 2A, because B is the same thing as 2A. Now we can go ahead and simplify this expression right here. So we're going to write 2 times, all right, if we square 2, that's 4, so that's 4A squared plus our 1A squared right here. So we have to double 5A squared, which is equal to 10A squared. Now what we should notice here is we have an expression that represents the shaded area in terms of just A. So what we can do here is write that as our numerator. Now, what we should also understand here is that we can just cancel out the A squares, and we have 10 over 25, which is our fraction. And we can simplify that, of course, to 2/5. So we can say that 2/5 of the entire figure is shaded by those blue squares.
Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and enable notifications so you can be informed as I upload new math tutorials to my math channel. Until next time, this is Shane Masonette with Masonette Math.